Introducing conditional probability. Suppose a study of speeding violations and drivers who use cell phones produced the following fictional data. Speeding violation, no speeding violation, use cell phone while driving, does not use cell phone. Usually we are given a 2 by 2 or a two-way table. Even if the total are not included, we should go ahead and add the total along the rows and along the columns. If we get the total along the rows and along the columns, then the grand total should be the same regardless whether we add the last row or the last column. Before we compute any probabilities, let's understand the table a little bit more. The table consists of the number of used cell phone while driving. There are 305 people who use cell phone while driving. Out of 305 people who use cell phone while driving, 25 got the speeding violation and 280 got no speeding violation. Similarly, there are 450 people do not use cell phone. Out of these 450 who do not use cell phone, 45 get the speeding violation and 405 get no speeding violation. Similarly, there are a total of 70 people who got the speeding violation. Out of these 70 people who got the speeding violation, 25 people use cell phone while driving and 45 people do not use cell phone. There are 685 people who got no speeding violation. Out of these 685 who got no speeding violation, 280 use cell phone while driving and 405 do not use cell phone. There are a total of 755 individuals in this sample. Calculate the following probabilities using the table. Find probability that the driver is a cell phone user. To find the probability that the driver is a cell phone user, we will simply find the number of cell phone users divided by the total possible individuals included in this sample, which is 755. Out of these 755 people, how many of them use cell phone? Use cell phone, whether they have the speeding violation or no speeding violation, the total of people who use cell phone while driving is 305. And so the answer is 305 over 755. We will simplify it to a decimal number, but for now just leave this as it is so that we can refer this back to the table where the 305 comes from. Part B. Find the probability that the driver had no violation in the last year. Similarly, out of 755, how many of them had no violation? No violation whether they use a cell phone while driving or not. There are 685 people who did not have any speeding violation. So the answer is 685 out of 755. Find the probability that the driver had no violation in the last year and was a cell phone user. We're looking for the intersection and what they have in common. What they have in common is that no violations, no speeding violation in this column here. But there are three numbers from this column. Which one should we choose? And was a cell phone user. Cell phone user is this row. And so it is an intersection of this column, no speeding violation, and cell phone user, this row. The number that is in that intersection is 280. 280 of them had no speeding violation and used cell phone while driving. And so the answer is 280 over 755. Part D. find the probability that the driver is a cell phone user or the driver had no violation in the last year. For the or, we are looking for whether the driver is a cell phone user or had no violation or both. Remember the definition of or. And so out of 755, how many of them are cell phone user? 305. Or how many of them had no violation? 685. But notice that when we use the number 305, which is from the row use cell phone while driving, and the number 685, no speeding violation, we counted 280 twice. 25 plus 280 to get 305, and 280 plus 405 to get 685. We use 280 twice, and so we would need to subtract what we counted twice, 280. And the answer is 710 out of 755. We can use Venn diagram to demonstrate this example. We let A be the event that the driver used cell phone. B be the event that the driver had no violation. And we're looking for the probability of A or B. Using the Venn diagram, we draw one circle for A be the event that the driver used cell phone while driving. And we draw another circle for B, no violation. And we assume that there is something in common here when we draw a Venn diagram. The first event is A, the second event is B. There are 305 drivers who use cell phone while driving. To get that number 305, we take 25 plus 280. So we use 280 once here. There are 685 drivers who got no speeding violation, and to get that 685, we took 280 plus 405. This time we use 280 again. And A and B have something in common, and that is the 280 who used cell phone while driving and had no speeding violation. When we took 305, which is the entire circle A, plus 685, which is the entire circle B, we included the intersection, the part that they have in common, twice. And that is why we need to subtract 280 to get rid of the part that we double counted. The intersection, or the part that they have in common, is 280. Out of 305 drivers who use cell phone while driving, 280 got no speeding violation. This is the part that is overlapped with B, and 25 of them got speeding violation. 25 is the part that includes only those who use cell phone while driving and have speeding violation. Similarly, there are 685 drivers got no speeding violation. Out of those 685, 280 use cell phone while driving, and therefore 405 do not use cell phone while driving. And these 405 who got no speeding violation do not use cell phone. If we take 25 plus 280 plus 405, these are separated pieces in the Venn diagram. We took care of the overlap part already. 25 plus 280 plus 405 should give us 710 out of the ground total of 755.